Welcome to myprojectbuzzer.com. Here we discuss about a high efficiency non-isolated bidirectional DC to DC converter with zero voltage transition. In recent years, the development of high power isolation bidirectional DC to DC converter has become an urgent topic because of the requirements of fuel cell vehicle applications and battery-based energy storage system, where a bidirectional DC to DC converter is needed for cold start and battery recharging. For cold start, the DC to DC converter boosts the 12 volt battery voltage to a desired high voltage, normally 150 to 300 voltage, for the fuel cell to start. Once the fuel cell is started, the DC to DC converter recharges the battery from the fuel cell or regenerative braking. In order to increase efficiency, soft switching technologies has been widely used in DC to DC converter. However, most of the existing soft switched DC to DC converter are low powered, unidirectional, and often are difficult to meet the requirements of the above applications. With the limited fossil fuel problem, renewable energy becomes the center of public interest. Therefore, power electronics applications is applying to alternative energy applications fields such as photovoltaic generation, fossil fuel, and electric vehicles because it became a matter of common interest. In these applications, an energy storage system like a battery system must be needed to save and use energy. Thus, a bidirectional DC to DC converter which allows a transfer power between two DC sources between an independent and important topic of power electronics. The bidirectional DC to DC converter is categorized into an isolated converter and an non-isolated converter. The demands of bidirectional DC to DC converter are smaller sizes, lighter weight, and higher efficiency, etc. In order to minimize the size of conventional bidirectional DC to DC converter, the switching frequency must be increased. However, the increasing of switching frequency results in higher switching losses. General method to prevent efficiency drop is that auxiliary switching without auxiliary circuit are employed to help the HVC and HCC operation on the main switches. Although the bidirectional DC to DC converter using only two auxiliary switches shows better performance than conventional bidirectional DC to DC converter, the two auxiliary switches operate under hard switch conditions and check the materialization of high efficient converter. In our proposed work, we use bidirectional converter. A simple auxiliary circuit has been applied to provide soft switching at both modes of operation. By adding the resonant cells, the converter can realize zero voltage transition, where both the switch and the rectifier diode achieve soft conditions without increasing their voltage and current stresses. Now I am going to explain flow diagram of our project. In the first stage, we give the input DC supplies, and this DC supply was fed back to the signal, and this feedback was given to error amplifier. Here we using triple RM system to control the total switching devices DC to DC converter. This will generate the pulses of triggering pulses for according to the error signal which are extracted from the error amplifier. Here, this structure was composed by using the non-isolation structures of DC to DC converter. The signal which are extracted from triple RM system was fed to the comparator. This will compare reference signals and the signal from triple RM system and generate the pulses regarding to controls the switching devices which are present in DC to DC converter. Then finally, this regulated DCs was fed back to the microgrid applications to generate inverted supplies and provides the three-phase at load side. Then finally, this structure gives regulator DC to DC supplies from unregulated DC input which are extracted from PV system. The PV system output was irregular DC inputs which are gives the DC voltages regarding with the temperatures made in the solar panel. According to the solar panel voltages, we can extract the unregulated DC supplies and gives the feedback signals and generates the error amplifier signal and pass to tribolorum system. From the tribolorum system, this gives the control pulses to DC to DC converter which are proposed by non-isolated bidirectional DC to DC converter. Then the signal from comparator gives the regulator and this regulated DC was fed back to microgrid applications to provide the AC output for AC load. Now I am going to explain running procedure of our project. In the initial case, we design the PV systems and from the output of PV system, we connect the total PV output with our proposed DC to DC converter circuit. Then from the DC to DC converter circuit, we provide the DC load at the end. To give the triggering pulses for CMOS switching devices or BCJR switching devices or IGBT switching devices, we get the feedback result from DC load and gives to tribolorum controller. The controller which generates the pulses to trigger the on-state and off-state durations of CMOS or IGBT switches in the DC to DC converter. Here we also interconnect the microgrid combination with the load supply at the DC output from DC to DC converter. Here we use the inverter circuit to generate three-phase supply of AC signal to the load side. Here the load side will have the motor to run a fuel-based structure. Here once at the initial conditions, the DC output from DC to DC converter turn on the motor and it also charging the batteries while from the PV systems. The tribolorum system gives the triggering pulses for the controlling signals to generate the regulated DC to DC converter by maintaining the switching step while the input of PV system in irregular voltage supply. This also fed to the microgrid applications to generate AC signal, either single or three-phase AC signal. At the end of microgrid application, we place a motor to run the load side AC load. Even though the PV system was varying very high, the DC to DC converter may regulate in the isolated manner with the help of bidirectional DC to DC converter. Thus we extract the regulated and noise-free DC output from our proposed DC to DC converter.